Alright, let's move on to the next question. Very important question asked n number of times, almost in every single PU board paper for Karnataka. Okay, the relation between electric field and electric potential. Okay, a very commonly asked question. So let us see what we have to learn here. Let us say there are two equipotential surfaces A and B, okay, separated by a small distance, let us say dr is the distance. Okay, so I can write here the distance is dr. Okay, let us say the potential for the plate A is V, for potential for plate B is V minus dV. Okay, so how we take this as, you can consider a small charge over here because of which the electric field is going this way upwards. Okay, so electric field direction I have drawn, I'm sorry, the electric field direction has been drawn. Okay, I'll just redo it. Just a minute. Okay, okay, in this figure, one is two equipotential surface has been taken. One potential is more than the other potential. The equipotential surface A is obviously closer to the charge Q and B is a little far. So obviously A will have potential V, B will have lesser potential. So we have given V minus dV. Electric field direction is from A to B, any upwards it is. Okay, so this is the basic. So how will you write the initial explanation? I'll just dictate, consider two equipotential surfaces A and B spaced closely. Let the potential of A be VA is equal to V and the potential of B VB, let it be V minus dV. Okay, and now I have also given you the direction of electric field. So initial explanation is just explaining equipotential surfaces A and B, distance between them and what are the potentials they have. Once you know this, now what is the direction of electric field? It is normal to both the direction of electric field is normal to both A and B. Okay, now what we need to do is we take a unit positive charge. Okay, and we move from B to the surface A. We take a unit positive charge on B and move it towards A. Okay, so when you do this, you are doing it against the electric field, isn't it? So we need to do some work. If I had taken a charge, unit positive charge, and moved it from A to B, work done would have been 0. Now we are moving from B to A, from smaller potential to higher potential, so we need to do some work. Okay, so after writing the initial explanation, we can directly tell when a unit positive charge is taken from surface B to surface A against the electric field, work is done. So by definition of work, okay, work done to move from B to A, to move a unit positive charge from B to A is VA minus VB. VA minus VB. VA potential given is V minus VB potential is V minus dV. So using that you get dV as the answer. This is your first part from the definition of work. Okay, and the other way of writing work also, you can write also work done is work done WBA can be written as EDX or EDR, E dot dr. From where am I getting this? Just let me tell you. Work done is equal to force into displacement F dot S स्टैंड फार्मूला. F के बारे में हमने ऑलरेडी इस फॉर्मूले में पढ़ा. E इज इक्वल टू F बाई क्यू. F इज इक्वल टू ई क्यू आएगा, तो ई क्यू एंड एस आ जाएगा. ओके, यूनिट पॉजिटिव चार्ज मूव कर रहे हैं तो उसका कोई काम नहीं है. ई डॉट एस आएगा एंड नाउ ई की जगह एज इट इज़ ई रहेगा, एस की जगह हम मूव कर रहे हैं डी आर, सो ई डॉट डी आर आएगा. सो यू गेट ई डी आर cos theta here is 180. Why? E, you can see the figure, E is upwards movement, dr is moving downwards. We are moving the unit positive charge downwards, B to A. Electric field is from A to B, so the angle between E and dr is 180. So you get minus EDR over here, minus EDR. So this is your first equation, this is your second. Comparing the two equations, you get minus EDR is equal to dV. Okay, with which you get E is equal to minus dV by dr or dV by dx, whatever from your textbook, you can take both of them. E is equal to minus dV by dr will be your final formula. So this is a very important question yet very simple. All you need to know is दो इक्विपोटेंशियल सरफेस लेना है और उनमें से एक का पोटेंशियल v रहेगा, दूसरे का पोटेंशियल v माइनस डी वी रहेगा. इलेक्ट्रिक फील्ड डायरेक्शन डाल देना है. यूनिट पॉजिटिव चार्ज शुड बी मूव फ्रॉम b to a, so some work needs to be done against it. So that work done is va minus vb. So that v and v minus dv सब्स्टिट्यूट करके dv मिलेगा, पहला वर्क डन. दूसरा वर्क डन है डेफिनेशन से, वर्क डन इज इक्वल टू एफ डॉट एस से मिलेगा ई डॉट डी आर. ई डॉट डी आर बनेगा ई डी आर कॉस थीटा. थीटा 180 है, इलेक्ट्रिक फील्ड ऊपर है, वर्क डन. मूवमेंट नीचे की तरफ है तो कॉस थीटा 180 बनेगा, तो माइनस ई डी आर मिलेगा. दोनों को सब्स्टिट्यूट करके क्रॉस मल्टीप्लाई करोगे, ई इज इक्वल टू माइनस डी वी बाई डी आर मिलेगा. सो दिस is a very important derivation. And here what does the negative sign shows? Negative sign shows that the direction of electric field is in the direction of decreasing potential. The direction of electric field is in the direction of decreasing potential. I think I can show you here. Electric field direction ऊपर की तरफ है and potential कम होता जा रहा है. तो माइनस साइन दिखाता है कि इलेक्ट्रिक फील्ड का डायरेक्शन, जिस डायरेक्शन में पोटेंशियल कम होता जा रहा है उस डायरेक्शन में इलेक्ट्रिक फील्ड होगा. So that is what it means. I hope this particular question is clear. A very important question. Please practice again and again. Okay, and it's a must-ask question in your final exams. Okay, and make sure when you write the explanation properly. You write the reasoning properly. Okay, and you mention the equation 1 and 2, and you write here equation from equation 1 and 2, and then you write all the substitutions and make sure to put it in a box at the end. Okay, that is the way you present in the exam to get full marks. I hope this is clear. We'll meet in the next session for a next important question. Thank you.